Is it possible to have a backup of your brain in the cloud? The same way your phones has a backup, your picture has a backup, your documents are backed up. Even when you lose your phone, you could buy another one, log in, and restore almost everything. But what about your brain? If you lose a memory, there's currently no backup file somewhere waiting for you. But after looking at technologies like NEO and Neuralink, I started asking a rather uncomfortable question. Could we eventually back up information from our brain into the cloud? Sounds like science fiction, but interestingly, some of the pieces required to make something like this possible are already being researched. Welcome to Smart Careway. I am Samuel Awowo. Let's engineer the healthcare future together. In my previous video, we talked about NEO and Neuralink. Now, remember what these technologies are doing. NEO can record brain activity. When a person imagines moving their hand, a computer interprets that signal and uses it to control a robotic glove. Neuralink telepathy works on a similar principle. Neural signals associated with intended movements are converted into digital commands that can control computer and other devices. Think about what has happened. Information started inside the brain. It was captured, converted, processed by a computer, and used outside the body. That is already a very important bridge. But backing up your brain would require us to cross a much bigger one. Because recognizing I want to move my hand is different from extracting I remember my mother's voice, or this happened to me 10 years ago. A memory isn't simply sitting somewhere in your brain like a video saved inside a folder. Memory involves complex patterns of activities across network of brain cells. So before we even ask, where do we store the backup? The first we have to answer is, what exactly are we backing up? And this is where things become interesting. Researchers are already experimenting with what we might call a memory prosthesis. In a 2024 human study, scientists recorded activities from the hippocampus. Hippocampus is part of the human brain responsible for learning, managing emotions, and turning short memory into long-term memory. So they developed a stimulation pattern based on the person's own neural activities. And when certain patterns were stimulated back into the brain, memory performance improved under some conditions. Now, let's be very careful here. They did not download somebody's memory. Nobody saved Christmas 2024.mp4 into a computer. But what they began to understand were patterns associated with how particular information was being encoded. And that distinction is massive. For a true brain backup system, we would eventually need something like this. Read neural information, understand what the information represents, convert it into something the computer can store, retrieve it later, and somehow communicate meaningful information back to the brain. At the moment, scientists can only do a fragment of that chain and not the entire process. And just to understand how difficult this is, researchers from Harvard and Google reconstructed only 1 cubic millimeter of human brain tissues at extraordinary details. These tiny pieces contained around 57,000 cells and about 150,000 million synapses. And the imaging and reconstruction produced approximately 1.4 petabytes of data. Now, this doesn't mean 1 cubic millimeter of your brain can store the capacity of 1.4 petabytes, but it shows you how ridiculously complicated the structure we are trying to understand actually is. Interestingly, scientists have already proposed something called a human brain cloud interface, known as BCI. The idea is that one day, instead of your brain communicating with only one small implanted computer, it could communicate with powerful external computing systems. But here's where I think people misunderstand the idea. The first realistic version may not be upload the entire brain. It may be something much more simpler. Cloud-assisted memory. Imagine meeting someone in a conference and years later you think, where did I meet this person? Instead of picking up your phone and searching, a future brain computer system could potentially recognize what you were trying to recall, search for the information stored externally, and assist you in retrieving it. The cloud isn't becoming your memory, it has become an extension of your memory. And suddenly, your phone isn't in your hand anymore. The interface is directly connected to you. And this is where things stops being just an engineering discussion, because if information from your brain can eventually reach the cloud, we have to ask, who owns the information? You, the hospital, the company that manufactured your brain implants, or the company providing the cloud server? What if the system learns things from your neural data that you never intentionally shared? Can neural information be deleted? Can it be copied? Can AI analyze it? Now, these concerns are already serious. Organizations such as UNESCO are developing ethical protection around neurotechnology, mental privacy, and neuro data. So, no, we cannot currently back up the human brain in the cloud. NEO and Neuralink are not uploading people's memories, but they are demonstrating something very important, that information can travel from the human brain into the digital world. The next question is, how much of that information will we eventually learn to understand? Because perhaps the future isn't about putting your entire brain into the cloud. Perhaps it's about giving your brain access to one. And if that future arrives, would you connect yours? I am Samuel Awowo, and this is Smart Kerway. Don't forget to like, share, and subscribe. I'll see you in the next one. Peace out.